Hello there, 8th graders. This is Mrs. Minowitz, and I'm here today to talk to you about volcanoes and earthquakes. So we're going to start with volcanoes. So in the United States, there are 70 potentially active volcanoes, and there have been more than 50 different volcanoes that have erupted in the past 200 years in the United States. So the United States is a pretty volcanically active area, especially when we are talking about places towards the Pacific coast, such as Alaska, California, Washington, Oregon, and also Hawaii out in the Pacific Ocean. The United States actually ranks third behind Indonesia and Japan in the number of historically active volcanoes. So we do have a lot of active volcanoes in the United States. One of the main things we need to know and that we should have that we've talked about in class is that most volcanoes and earthquakes occur at tectonic plate boundaries. The key word here is most. It is certainly not all. There are volcanoes that are formed by hotspots, which happens usually in the middle of a plate, and there are earthquakes that happen all over the place, not just at tectonic plate boundaries, but many or most of them do occur at the edges of our plate boundaries. So if we look at our plate boundary map, this is where you're going to be more likely to see volcanoes and earthquakes, but again, there are many that do not occur along those plate boundaries. One of the things I want to make sure we understand is the difference between magma and lava. I've used both of those words in class, and we've talked about and used those words, but I want to make sure we understand the difference. Magma is molten rock that it has melted inside a volcano, and it is under the surface of the earth. That is magma. However, when it is molten rock that has erupted or is above the surface of the earth, then we call it lava. So it's essentially the same thing. We're just talking about where it is located. Now, there are some different types of volcanoes that we're going to talk about. There are more than the ones that we talk about here, but we are going to talk about 3 different types of volcanoes. The first one that we're going to talk about is a composite volcano. This type of volcano has both non-explosive and explosive eruptions. So it might have lava coming out of it that's not like a huge kaboom, or it might have what's called pyroclastic material coming out of it, which would be things like ash and things like, shown here, volcanic bombs, basically big rock fragments that come out of a volcano. Places where this would happen would be the Ring of Fire. Example is Mount Fuji in Japan. And this is a composite volcano. This is an example of what a composite volcano looks like. A lot of times when we think of volcanoes, we think of composite volcanoes. That's kind of the image that a lot of times we have for a volcano. More than half of the active volcanoes in the world are located in the Ring of Fire, and many of those are composite volcanoes. So if we look here, we've got the Ring of Fire, which again we know is around the Pacific Ocean, and this is showing different trenches and areas where we commonly get volcanic activity, also earthquakes. The second type of volcano that we are going to talk about is a shield volcano. These are non-explosive eruptions, so it wouldn't have like a huge explosion when something comes out of it. These happen very frequently in Hawaii. Hawaii is mostly shield volcanoes, and if you look here, you can see a shield volcano. It is not nearly as steep for its slopes because its lava is much more runny, so it kind of like spills out and forms this big volcano that's more gradual slope than a composite volcano. Another example of a shield volcano is Tamu Massif, and this one was discovered in 2013, and it is one of the largest known volcanoes, but it is underground, and it actually occurs over off of the coast of Japan here, and it's underground, but it'd be one of the largest volcanoes ever to be discovered. It's just underground. Another type of volcano is called a cinder cone volcano. These ones have explosive eruptions where they a lot of times have ash, rock, and debris that get exploded out of them. One example is Paricutin in Mexico, which was one of the landforms from the Landforms Project. And basically what this volcano formed is there's all sorts of ash that just started coming out of the ground and rocks that over time formed the slope of this volcano. Here's another picture showing what a cinder cone volcano looks like. something else that we need to know as we're talking about these different processes is the difference between a constructive and a destructive force. So a constructive force builds matter up. We are constructing something or making something. This could be, for example, when we have a mountain being formed. A destructive force wears matter away. A great example of this is if you look at Mount St. Helens. This is in Washington State, and this picture here is from before this volcano erupted. And then if you look at it afterwards, it essentially blew its own top off. This would be an example of a destructive force because we went from this to this. Okay. So there are other types of volcanoes. We're only going to talk about those three in this class. We're going to now move on to earthquakes and some information about different types of earthquakes. So to measure how large or how strong an earthquake is, there's what's called the Richter scale. And the largest earthquake that was recorded was in Chile, and it was a 9.5 out of 10 on the Richter scale in 1960. That is extremely most volcanoes that are most earthquakes that are very strong we're talking a 7 or an 8 on the scale. 9.5 is very, very strong. This was very devastating to the people of Chile just because so many things were destroyed by that. One thing I want to make sure that you understand, though, is that earthquakes can occur anywhere. This is from a paper nearly 10 years ago now showing where a earthquake happened in Illinois. Okay, Illinois is not at the edge of a plate boundary, is smack dab in the center, but it can still have earthquakes. They're just not nearly as common as they are along the plate boundary. Faults, again, we have talked about in class. And again, a fault is just where rocks break and move. It's a break in the Earth's crust, and we get movement along there, which is what causes our earthquakes. One very common or well-known fault is the San Andreas Fault, and this runs through California. You can see here in red where it goes. And if you look here, we have the arrows pointing in opposite directions like they're sliding past each other. So this is an example of a transform plate boundary, and this is occurring at what is called the San Andreas Fault. When earthquakes happen, we have what are called seismic waves, and these are waves of energy that make the ground move during an earthquake, and there are different types of waves that are formed when an earthquake happens. The focus is also called the hypocenter, and this is the point inside the Earth from which the seismic waves are produced and travel. So this is generally below ground, okay, where an earthquake is actually happening, where things are actually start moving and is producing those waves. The epicenter is directly above the focus on the surface of the Earth. So the only difference between the hypocenter and the epicenter is that one is on the surface of the Earth and one is below it, where the earthquake actually started. And we're going to be looking at finding the epicenter of an earthquake, triangulating how far away it is from different seismic stations, and using that information to actually figure out where an earthquake would have occurred. There are three different types of seismic waves that we're going to talk about in class. The first one are called P waves, or primary waves. That's because they are the first waves to arrive. They are produced at the focus. They travel at 6.1 kilometers per second, and they travel through both solids and liquids. The first one's there the fastest. These ones are often not felt by humans. They're really small, but some animals can sense the vibrations or hear the waves, and that's sometimes why certain animals will seem to know that an earthquake is happening even before it does, because humans haven't figured out yet, because we haven't been able to feel the other waves yet. The second type of waves are S waves, or secondary waves, because they get their second. These again are produced at the focus. So they would be underground. They travel at 4.1 kilometers per second, and they only travel through solids, which is actually how scientists figured out that parts of the center of the Earth is liquid, because the S waves didn't travel through them, and they didn't get some expected data if they would have traveled through a liquid. They just travel through solids. The last type of wave is called L waves, or love waves, after the scientists who did an extensive amount of work on them. These are surface waves. These are produced at the epicenter, so that would be above ground, okay, or on the surface. These are different because they're not below ground. These travel at 1 to 5 kilometers per second, depending on a lot of different factors. These are the most destructive because these are the ones that are found on the surface, which is where people and buildings and things like that are located. We will talk more about both volcanoes and earthquakes in class. We'll see you then.